Hi, this is Design and Analysis of Algorithms, first exam part 3. Here I'm going to explain how to solve root functions recurrence relation. I'm selecting this function. Here the function is t of n equal to t of root n plus log of n into log of n. By we can clearly say that it is a root function since it contains some root values. Here we can see that it contains root n. When we show these root functions, in order to solve these, first we have to convert these root functions into dividing function. In order to convert these root function to divide function, let me consider that n is n equal to 2 power m. After considering n equal to power n, here applying the log on the both sides, so it will become log n equal to m log 2 power m. 2 power m becomes actually it's log a power b, means b log a. So log 2 power m will change to m log 2 base 2, while log 2 base 2 is value is 1. So log n equal to m. Here I have substitute the 2 power m with n. T of 2 power m equal to 2 power root n value is nothing but n power 1 by 2. So here the value becomes 2 power m by 2 plus log n is the m as shown here. So we replace log n with m. After replacing, after doing this, we have to replace, since it is not in the dividing function format of dividing function, we again apply t of 2 power m with s of m. Then the function will change to s of m equal to s of m by 2 plus m into m square. Now it is in the format of dividing function. Here the dividing function has to be in this format: t of n equal to at of n by b plus f of n, where t of n equal f of n equal to n power k log power p n. See, if you observe, this function is in the same format. So from by seeing these two functions, we can say that a value here it is 1 and the b value is 2 and f of n equal to m square. So I have applied dividing function here, Marshall's theorem's dividing function. As here it is 2, b becomes 2, n power k. Here in place of n we have taken consider the m. M has the power of 2, so k becomes 2. Here log power p of m. Here there is no log function. If there is no log function, we can consider it as 0. If we have the log function in the divided by, then we can consider it as -1. If it is the log function besides to m square, then we can consider the p value as 1. So as we know that this is in this format, now we have to calculate log a base b, and we have to compare the log a base b value with k. Then we can say that the particular function comes under which case, under master theorem. If you see here, this is the master theorem. Here we have the formulas. See, if the log a base b value is greater than k, then it is order of n power log a base b. The case 2 is log a base b value is equals to the value of k, then again it is divided into three functions based on the value of p. If the value of p is greater than -1, then it is order of f of n log n. If the value of p is equal to -1, then the order of n power k log of log n. If the value of p is less than -1, then it is order of n power k. This is the case 2, when log a base b value equals to k. Now we'll see the case 3. Log a base b less than k. When the value of log a base b value is less than the value of k, then again it is divided into 2 based on the value of p. If the p value is greater than or equal to 0, then it is order of n power k log p power p and n. If the value of p is less than 0, then it is order of n power k. Now we'll see the value, compare the value of log a base b in our function. First we have to calculate the log a base b. Here a value is 1 and the b value is 2. So log 1 base 2 value is almost nearly 0 and the k value is 2. We can clearly say that log a base b is less than k. So here we have to check the cases under which case it is getting satisfied. Under case 1 log a base b is greater than k, under case 2 log a base b is equal to k, case 3 log a base b is less than k. Whenever it is less than k, we have to again check three values. In this case, here log a base b is less than k, so it becomes the case 3. So case 3 again we have to check the p value. Here p value is 0, so it comes under this case, order of n power k log power p of n. So order of n power k log power p of n. Usually we'll, by mistake we generally will think that we'll apply the k value and the p value here, and this will be the resultant resultant function. But here we are doing the operation from starting in m, so in terms of m, so we have to consider the n as m. So here order of m square log power p, which means 0 of m, log power anything power 0 is 1, so this value becomes 1 and the resultant is m square. Here if you see m square means log n, so here the resultant function is order of log square n. The recursive relation is order of log square n. In the similar way, if any other root functions also is there, first we have to consider, we have to take that function and substitute the n equal to 2 power m, and after that apply and substitute n value as 2 power m. Here if you have any doubt in how this became m by 2, you can apply log here. If you apply log, it becomes m log 2 base 2. If here we have to consider as base as 2, if log 2 base 2, then it is 1. So t of m by 2 becomes m by 2 log 2, which becomes t of m by 2. So we are replacing t of 2 power m as with s of m. S of m equal to, by replacing this we have to we have to convert these in the form of dividing function. After converting it to the form of dividing function, we have to compare the r function with the dividing function, and after that we have to compare the values of log a base b in order to see under which case it is to be, it is in Master's theorem. So by calculating the log a base b, we are getting the we can clearly see that log a base b is less than the value of k. Then if it is, this is the case, then it is the case 3 in the Master's dividing theorem for dividing functions, Master's theorem for dividing functions, and p value is 0. So it is order of n power k log power p of n. As we are calculating in the form of m, we have to replace n with m here, order of m square log power 0 of m, log power 0 becomes 1, order of m square. We have to we don't leave like this. After you're getting order of m square, we have to we have to submit the m value as login. Here we are getting the m value as login, where we can apply log both sides, so we'll get m equal to login. So here we are applying m as login whole square or log square n. Thank you.